Hi, so this is the first part of the lab where I discuss how I use floating point precision to calculate the value of pi. So this is the infinite series I use to calculate pi. So essentially for every even index in the series, I find if it's an even index by the index modulo 2, and if it's 0, it's even. I add it to the current value. I add this calculation to the current value. So essentially I take 1 over 2 times the current index plus 1, which is the formula that's used in the documentation. And to account for odd numbers, if it's an odd index, I'll subtract it from the current value. But it's the same formula. So at the end of all this, I actually multiply the value times 4, since this actually calculates the value of pi over 4. And the way I check how many iterations it takes is I set boundaries. So for example, I'm looking for something in between 3.141 and 3.142, which would give me 3.14 or 3.1415, somewhere around that range, which is what I'm looking for in terms of accuracy. So once this boundary is reached, the for loop breaks, and then I can check the iteration, how many iterations it took, because the counter variable will be locked in essentially at what the last iteration was. And these numbers are just 3.141 and 3.142 divided by 4, because this is 1/4 of pi. And this is where I record the ending time for a systic, and this is where I record the starting time. And that's how I calculate the total time it took for it to calculate the value of pi. And here I multiply it times 20.38 nanoseconds, because the clock is operating at 48 megahertz. And then once I have nanoseconds, I divide it by 1 times 10 to the 9 to calculate how many seconds it took. So now I'm going to compile this and run it on this Launchpad right here. So I've set expressions to be able to view global variables that were set before the main function. So I'm going to step through this. And so now the for loop is executing, it stopped executing, and now we have our value of pi, which was found to be 3.141 after 1,696 iterations, and the time elapsed was around 5/600ths of a second for the floating point implementation.